Hey, I am Andre from Aurora School for Artists, and in today's video, I would like you bring something closer to basic concepts of game development. Afterwards, I hope that you have one better basic understanding of it. What elements exist in virtual 3D worlds, what properties they have, and how they are connected. Why am I telling you anything now at all? To the basic concepts of game development. When our focus, actually, on the development of augmented reality apps, lies in the artistic realm, the answer to this is relatively simple. AR apps are interactive real-time systems. They react quasi to the interaction, which I perform with my smartphone, for example, tap on the display, or simply move the smartphone. And at the same time they update, continuous, virtually in real time their output. The image on the screen, music that is played, etc., etc. One other prominent example of interactive real-time systems are computer players. They have quasi very many similarities with these apps. Both live in three-dimensional space. Both have most different input and output methods. And as you probably all know, now exists one huge market for computer games, and accordingly also one quite large market for computer game development software, the so-called game ring. In the meantime, it has developed like this, that these games engines also support for AR app development, or even offer virtual reality apps. What actually turns interactive systems on? I have just mentioned it before. On the one hand, they offer different input methods, be it mouse and keyboard game controller, the touchscreen of the mobile phone, or completely different methods, like webcams or a wide variety of sensor technology. These inputs are then processed by the computer. And based on the processing, the computer generates an output. For example, on the screen, in virtuality glasses, or as audio output, or on M, or on cell phones also as vibration. To provide these functionalities, computer game engines offer various modules. There are, for example, modules for the input. There are modules for the output, be it in audio, be it for graphics. However, there are also modules who deal more closely with virtual characters living in the worlds, how these are animated, how they also find their way through the worlds. And of course, you can make sure that the virtual worlds also obey physical laws. For this, computer game engines offer modules for physics. In addition, you can also use the engines to add your own modules. For example, to control the logic of the application or the game. In addition, there are still many other modules with special purposes. One looks at the theme of graphics. Then you find that technically it actually is very strongly related to the film. Effective, you generate a lot of frames and plays these so fast off that it works like this for the human eye, like a seamless animation. In the film, these frame rates are usually fixed. Say you have a video, what a frame rate of 24, or has 30 frames per second. In the computer games it is often variable, and dependent on it, how much the computer just happens has, for example, based on how complex the scene is, or how complex the current perspective is. Simply, you can say that the perception if something is seamless or not is very person-specific. On the other side, but it is also very strongly dependent on the type of game. Games that you look at from a first-person perspective usually require a higher frame rate for a round game feeling than games looking at the world from a top-down perspective. At the same time, it is also strongly dependent on the medium. You use virtuality, for example, it is necessary generate at least 90 frames per second, since otherwise nausea often occurs. Central technical element of a game is the so-called game loop. After turning up the engine, a loop runs permanently, which has three important elements. First, the inputs are recorded. Based on these inputs, the game logic, or updated the logic of our application, and then the output is processed. For example, one frame on the screen changed, and this happens over and over and over and over again, in a loop, until I finish the game. Virtually shut down the engine. As well as in the real world, there are objects in the virtual worlds. Usually, we call them game objects. And they can be roughly categorized in visible objects, it can be 2D objects, or 3D models, or complete animated characters. On the other side, there are also a handful of invisible objects. For one thing, you can position lights in the world, whose effect you only see within the world. You can set up cameras that virtually determine from which perspective one image is rendered. You can position sound sources, or physical force fields that affect gravity. Or you can simply position zones, trigger the certain actions, so-called triggers. Just like real objects, game objects, naturally a variety of properties. One of the most important features is their position in space, which are indicated with the help of cathesic coordinates. Cathetical coordinates, you certainly still know this from school lessons. There you give a position in the form of an x and a y coordinate at. That would now be for the two-dimensional space. In three-dimensional space comes another axis. Add the z-axis that we have x, y, and z. Sometimes cathesic coordinates are very impractical if you want to move objects with it. Therefore, you also calculate into other coordinate systems, around like the polar coordinate system. Here it is so. That again in two-dimensional space has a coordinate to components. On the one hand we have the radius. This is the distance from the origin. On the other hand we have the angle, with which we practically have the red dot, can rotate by this radius. This is practical, for example, when we, let's say, want to move a planet around a star, since the mathematics behind it is much more accessible for the persons that programs this movement. Since you only have one coordinate, namely must change the angle. Next to the position, game objects also have a rotation in space. Into D we see here on the left side, there is a single rotation axis that you can turn. In three-dimensional space on the right side, there are the three axes x, y, z that we can turn around. And the angles are called Euler angles, respectively. In vehicle technology this is also called pitch and roll. And as perhaps already expected, game objects can also be scaled, so be changed in size. These three very important properties, position, rotation, scale, are collectively referred to as transformation. For those of you who are technically interested, they are even often stored together internally in a mathematical construct, an interpretation of the so-called model matrix, which consists of 16 individual elements. The virtual worlds we create consist mostly of a plurality of different game objects, which can also be related to each other. Therefore, in the game's engines, the game objects can be organized in hierarchies as children and parents, and what that means is that the children be transformed relative to their parents. For example, the moon moves around the earth. It moves with the earth when the earth moves around the sun, and the sun in turn moves around the center of the galaxy. Or here on the right side, we have the little male on the ship, and the male moves with the little ship. It is virtually relative to his parent game object, the ship, positioned or transformed. These hierarchies have, according to the fact that we have not only one cathesic coordinate system, but several at once, you can practically distinguish into local coordinates and world coordinates, and every object can be converted between these different coordinate systems. World coordinates of the we see here, in the example of our ship, are the red and the pink arrow. These give the position in relation to the origin of the virtual universe. The little character is, as a child of the ship, positioned relative to this. That means he can also have local coordinates relative to his parental element. Here the blue arrow. What you see, if you calculate it mathematically quickly, that these blue coordinates, the 1 and the -5, are actually just the difference of the respective world coordinates of both objects, from the ship and from the character. I had just mentioned that the game engines have a wide range of functionalities they already provide with which we can work. To use these functionalities, we need them in the form of so-called components put on our game objects. Effective, it works a bit like the Lego principle. One game object is in itself only the sum of its components, and if it has no component, then it also has no functionality whatsoever. The game engines now offer a wide variety of components. There are, for example, components in the area of graphics. A 3D object I want to see needs a shape, of course, the so-called mesh, and also a material, what determines its texture or its color. When I, for example, have a visual character, then I maybe would like to give components to the game object around the topic of pathfinding or on the topic of behavior so that it also acts somehow in the world. If necessary, I would also like to that my game object has physical properties, some weight, or that it should practically collide with other things. I need certain components for that, like a rigid body or a collider. One component that actually all game objects always have is the transform, whom we have just met. Beyond that, you can usually also write your own components in the form of scripts, and you can then also give them to one or many game objects. In some cases, dependencies also exist between different components. For example, material and a 3D mesh are rarely detached from each other because they are both needed by a third component, the so-called renderer, which first ensures that the object can be displayed. In addition, you can, when writing your own components, also access other components via program code. For example, I can write my own script and then access the material from this script, and, for example, change the color of an object. Last but not least, we have already seen that game objects usually do not exist alone. They form, in combination with many other game objects, together a complex virtual world. This world is usually also called scene, so a scene is just the sum of all game objects. One application, in turn, can consist of different scenes, and within of a scene can of course also game objects interact with each other. For example, when we watch this little game, where the dog has to collect the coins, then of course the dog must virtually interactly with these coins. When he touches her, something is supposed to happen. For example, the coin disappear, and one counter go up somewhere. And that's it for the topic. Basic concepts of game development. Many of the things you have seen today, or perhaps already knew, you will of course in the following videos, especially to Unity, find again. And when you then do your own exercises, of course you will also get to know some of the things in more depths.